Okay, so welcome to everyone that is currently here. I firstly have to admit I forgot that today is round 2 of Junior Chem Olympiad. So if you are involved in SJCHO, then I hope you are happy with how round 2 went. That also would mean that not everyone can make it today, as I've realized. So this is recorded as usual. And I may also just post it on my YouTube, right? None of your faces or your names will be there. Right? It's just me and whatever questions we talk about. So, but this is an open session, not SMO open. This is an open to everybody session. So I'm not going to screen through all the names. Anyone that wants to come in is most welcome to come in. Okay, and of course, if your friends want to join, just let them know they can join. Well, I hope that all of you have gotten the chance to look at the notes, sorry, at the questions. How much time you've had to try it really depends on how busy you were preparing for the SMO round 2 for some of you, or like Chem Olympiad today. I know physics leaks around the corner, so lots of stuff are happening. But yeah, for all of you who are just coming in, welcome. We are just going to be starting very shortly, going through as far as possible all of the questions. And the problem difficulty is a little bit different from how it will normally be in the regular lesson, for the simple reason that Open Round 2 is on this Saturday as well. Okay, so I've chosen the proving questions to be a little bit harder than usual, and therefore to compensate, the short answer questions are a little bit easier than usual. But this is going to be the format if you do continue with the class in the subsequent weeks. Right, so for those of you who are already regularly in this class, then for today, maybe I'll have a little bit less bandwidth to respond to you. So if there's anything after, you can just text me, and also I will upload the solutions to all the questions onto the portal, and we'll send it out to everybody. So don't worry about copying anything down. Yeah, so bottom line is that the questions in this class are going to be very broad in their difficulty spectrum. They will start off usually pretty easy, and then the peak difficulty is usually open round 2 or open round 1 for the 2 sections. Where open round 2 itself has a scale, right? So it can go up to the hardest open round 2 questions, and it can also be sometimes the easier ones where they could be arguably described as junior or senior as well. Also, just so that all of you are aware, this is not going to be repeating exactly the same questions. So if you were here in the last year or the last semester, then questions will change again, because I try to mostly use questions that are from recent contests, along with anything interesting that I just feel like talking about. Okay. So that's what this is. It's not going to be topical lessons. We are just going to have our 6 short answer questions, which you can see are these. And then after that, 4 proving questions, for which I said I've made 2, 3, and 4 a bit more similar to Open Round 2. Okay, so I think without further ado, we'll get started, even as I'm continuing to just check in the waiting room to see who else is coming in. Question 1 is just a welcome question. It's a welcome question. And for anyone who did it, you can just type your answer into the chat, and I will see whether you got it off by 1. Yeah, so by the way, right, in case you are just like popping in and you didn't have a chance to look at the questions in advance, that's okay for today. That's why this is just a trial and open session. For this class, the intention is for you to try the questions before the lesson. So it's called a problem solving class, not because other classes we don't do problem solving, but rather that you are meant to, get some extra practice in. And so therefore, this is a class that is meant to give you some interesting questions to practice with every week. Where every week doesn't mean that if one week you don't do the questions, you get a scolding. It just means that every week there exists a set of questions, and as far as possible, you would like to try them. Yeah, okay, so I've bought enough time in letting some of you key in your answers into the chat, and it does look like many of you are right, but a non-zero number of you probably have got off by 1. So yeah, indeed, the answer is 338. Minimum number of people that must be gathered to guarantee at least 2 of them have the same birthday, or at least 1 of them was born in February. You just find the maximum number without this happening. And the maximum number without these obviously is if I have got 365 days and take away all of the February. Or if you want to, if you include the leap year, it doesn't make a difference, right? It's still 337. And so the maximum number without these is 337. You add 1 more, and they will either have to land in February or they will have to repeat a day. I have nothing else to say about this question. Like I said, it's just a welcome to everybody question, and also to see whether you get off by 1. So if you got off by 1, condolences. Okay, question 2. Now this is where we get started with sort of the questions for real. Polynomials px and qx have real coefficients. When px is divided by x plus 1, x plus 10, the quotient is qx and the remainder is 2x. When px is divided by x plus 4, x plus 7, the quotient is qx and the remainder is 38x plus 18. Find the remainder when px is divided by x minus 1. Okay, so this is the standard remainder factor theorem kind of polynomial question. Very typical for SMO Senior Round 1. The slight difference in this question is that the quotient is the same. It's not just the quotient in qx is not a placeholder. The quotient is q of x is significant because both of them have the same q of x. So if you didn't use the fact that they have the same quotient, or you didn't recognize that this qx is the same qx, you thought it's just a placeholder, then you will not have enough information to solve the question. If you used it, then it just means that this divisibility condition can be written in the standard way. Okay, so these are your 2 statements. What do you want to do with these 2 statements? You can say you subtract, yes. You can also say that you equate them. You can say you compare them. Actually, all of those mean the same thing. You equate them, you subtract, you compare, all have the same meaning, which is that you are going to say both of them are equal to px, and therefore they are going to be just no more px inside. You can just find qx. Okay, I'll expand it just so that we have easy time doing the comparison. If you move this over, and move that over. You just get qx equals to negative 2x minus 1. So qx is negative 2x minus 1. Means that you know what px is. I can substitute it back into either one. I'll just use the first one. The second one should turn out to be equal. That's what it should mean. And then we know that we are actually trying to get the remainder when px is divided by x minus 1. Your remainder theorem tells you that it's just p of 1. So just substitute it in. Now, our class is going to have everybody inside, right? This is how this class is. And so you will, for those of you as you are at a higher level, it'll be a bit of revision. For those of you at a lower level, you're kind of just getting thrown right into the deep end. And then one or two of you who are in junior may be asking, how can the remainder be negative? Nothing wrong. For polynomials, when you're doing division, the remainder can be fractions, the remainder can be negative, the remainder doesn't have to look like 5 or something, right? Remainder can be 2x, it can be 3x, 38x plus 18, remainder can be negative 64. Nothing wrong with that at all. Okay. Question 3. Question 3 is an example of a question that can be asked in the SMO Junior. It can also be asked in the SMO Senior. It can also be asked in the SMO Open. Because it doesn't use anything factually beyond SMO Junior. However, it is confusing enough and tricky enough to manipulate that it could be asked anywhere. Some of you don't realize that because you thought that the answer is just 18. That is not correct. The answer is most certainly not 18. Now, is there a simple relationship between x to the x to the 4 and x to the x squared or x to the x to the 8? Is there a simple relationship between these? Yeah, the correct answer to that question is no, there's no special relationship. These when you see a stack of powers, right? The default order of operations is the one on top comes first. So x to the x to the 4 and x to the x squared don't have any like, oh, this is just the square of that. No, 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 no. If you took the square of this, that's just x to the power of 2x squared. You double the exponent, not that you get this. Okay, so it is not that x to the x squared is 2. Okay, so what then do we do? Well, many of the SMO questions, many of these kinds of problems rely simply on the fact that the x is nice. Meaning that if the x is not nice, you would be in trouble. There would be no nice way to handle it anyway. So if you look at this, can you guess what x is? Good for you if you can guess what x is. If you cannot guess what x is, then I'm going to just show you how we can sort of, systematically, in a way, extract out x because of the fact that these are the same number. So basically, I can just raise both sides to the power of 4. And if you are not confused by this stack of powers, you can move the 4 inside. It is 4 times x to the 4 as the exponent. And then you can move the 4 below and write it like this. So now we end up with x to the power of 4 equals to 4, right? Because something to the power of itself equals to 4 to the power of 4. Obviously, that just implies x to the 4 is 4. And so x squared equals to 2 and x equals to square root 2. Or minus square root 2. But if you didn't remember, the minus is kind of harmless anyway. So we can just put it in. For this one, x squared is now 2. So x to the 8 is the square of x to the 4 is 16. So it's actually x squared plus x to the 16. And x to the 16 is this thing squared again. So the correct answer is actually 258. Apart from it being something that can be asked in junior, senior, open, this is also the kind of question that could appear in the AMC, right? So for our class, a lot of times we are going to be heading towards the nearest competitions. And for many of you, after this week's open round 2 is over, for a few of you, the rest of us, like there aren't that many major contests. And the AMC season will sort of be the next ones in November. So this is also a very AMC style question. As is this one. Now, probability is something that you will find we don't really do as a topic very often in our regular classes, simply because SMO doesn't ask it that much, and also it is something that relies mostly on just having enough practice and being exposed to sufficient varieties of questions. So you are not going to be missing any knowledge for a question like this. So S is the set of numbers from 1 to 10. A and B, not necessarily distinct, are two randomly chosen subsets of S. So which means that A is a random subset, B is a random subset, and it may turn out they are the same. It also is possible when it says randomly chosen subsets, right? It doesn't say proper subsets. So I'm saying that it can be S itself, and it also can be the empty set. So that is also possible. Now, what is the probability that A is a subset of B? I'm pretty curious about the success rate for this question. If you have the answer or you think you have the answer, could you type it in the chat? I am quite curious about this. Like, how obvious is this to everyone? So seemingly not that obvious to many of you. What is the probability that A is a subset of B? If you take the wrong path, this sounds really, really, really messy. You're saying that, okay, so if my A is the empty set, then B can be anything. If A has one element, then B can have any of the other remaining 9 elements and so on. And it sounds really bad. That can still work, by the way, and I'll say something about it in a second. When it comes to probability and counting in general, in the very round one sense, you would like to just think of it as, how do I cleanly chop it up into smaller considerations? Now, smaller considerations means what? It just means that I want it to be mini tasks that are not too complicated to calculate and also easy to combine back. I mean, if it's just like 100 different cases that you need to go and do a PIE add, subtract, add, subtract, add, subtract, that is not going to be very pleasant. So what is the probability that A is a subset of B? A is a subset of B. Can we say that if X is in A, it is also in B? This is what subset means. If I say that your knowledge is a subset of my knowledge, that's not true. Because there's definitely something you know that I don't know. So if this is the case, I can think of it as the randomly chosen subsets is not going to be that I pick A and B immediately. I just have the numbers 1 to 10, and for each of them, I just have a 50% chance that I put them in A, 50% chance that I do not. And same for B. So place your numbers into A with 50% probability. One at a time. Now this will also give you a random subset, right? Because if it's all the numbers from 1 to 10, I just put it in or don't put it in. Half your subsets will contain it, half will not. So this is fine. Now, this, if I do the same thing with B, then I will have a random A and B. Now, why do I view it from this perspective? It's just that if I want A to be a subset of B, that means that for each number, it's either that it is in A and it's also in B. It is not in A, but it is in B. It is not in A, it is not in B. That's all okay. The one that I don't want is that it is in A but not in B, right? This is what subset means. So there are 4 equally likely outcomes of what happens to the number, and basically 3 out of 4 acceptable outcomes for each number. So therefore, your probability is just 3/4 to the power of that. Simple as that. But if you did the other way, which I described earlier, something interesting actually happened. So let me just show how that will look like if we were to sort of split it into cases of how many things do you pick from the first, how many things did you pick from the second. So what I can say is that how many things did I pick in, let's say, A? Of course, it can be 0, 1, 2, until 10. Now, the probability that you picked these particular numbers is going to be 10 choose 0, then choose 1, and all of these over 2 to the power of 10. So these are the probabilities that you got each of these outcomes. And given that the probability that B contains A is that this must be 1 over 2 to the 10, right? It must be, I contain all these 10 things. This one would just be 1, and then half, and then 1/4, because it's just the chance that I have these many things. So if I were to combine this, that means that my probability is this times this, plus this times this, plus this times this, and so on. I will just factor out 1 over 2 choose 1 over 2 to the power of 10. If we did it like this, do you notice anything interesting about this sum? It is just your binomial theorem, yes. This is just 1 plus 1/2 to the power of 10 expanded out. Right? This 1 over 2 to the something is just powers of 1/2, and then 10 choose that thing. So that is why if you were to do it this way, you will also get the same 3/4 to the power of 10, right? It's half to the 10 times 3/2 to the 10. Yeah, so this is one of the reasons why the more stuff that you know, the better your chances are. Because every time when SMO was recently over, right? Whether it be round 1 or round 2, so it's a very pertinent time to talk about this. Every time you see a solution and you ask, how would I have thought of that? If that was the only solution, then that's a valid complaint. But usually there are actually multiple different solutions. And the more tools that you know, it means that you have got the so-called nice solution, and then you have got the clever solution, you have got the messy solution. At least you have got more chances of somehow getting to the answer anyway. And that's what we are hoping to accomplish as we continue to learn all kinds of stuff. Okay, number 5. Let S be the set of numbers defined by floor of 2 plus root 2n, where n is a positive integer. What is the 100th smallest positive integer not in S? Okay, so what does this actually mean? Whenever you see a set like that, it is always useful to just write down a few terms to understand. So it's saying that it is floor of 2 plus root 2 is there. Floor of 2 plus root 2 times 2 floor of 2 plus root 2 times 3 and so on. And if let's say that we know that root 2 is about 1.414, then you will know that this is 3. 3.4 times 2, 6.8 or so, that is going to give you 6. And then this is 3.4 times 3 is about 10 point something. And then this will just continue. The next one, 3.4 times 4 will give you 13. And so you will know that there are going to be lots of missing numbers because it is jumping by 3 or 4 each time, right? Because 2 plus root 2 is therefore about 3.414. So it is going to be jumping by 3 or 4 every time. Lots of stuff are going to be missing. So if I ask you for the 100th smallest, not in S, it's not going to be that far away. The issue is that if I were to literally take the missing numbers and try to count it, I say, okay, 1 and 2 are missing, 4 and 5 are missing, 7, 8, 9 are missing, 11, 12 are missing. How am I supposed to know when the gap will have 3 numbers and when the gap will have 2 numbers? That would require me to know my 2 plus square root 2 to a lot of decimal places, and even then, it would be extremely unpleasant to calculate. But if I were to focus on the numbers that I do have, maybe that's actually better. I mean, that's just S. But when I look at it here, I realize that, no, if I know that this is 13, 13 is the 4th number, which means that there are 13 minus 4, which is 9 that have been skipped so far. Then, if I can find out where is it that 100 have been skipped so far, I am done. And so this is the saying that if I find this value, this is the number, and it is the nth term, this is the number of skipped positive integers up to this thing. Which means that I would like this to be around 100. Do I want this to be exactly 100? I would like it to be exactly 100, but I can't be sure, right? Because if let's say that this one tells me it's the 9 skip so far, this one 10 minus 3, which is 7 skip so far. If I want the 8th one, the 8th one is just here. I mean, it's in between, so it's okay, right? If let's say that I find that this is not exactly 100, it's okay, I can adjust. So I just need it to be around 100, which is good because floor functions are very easy to estimate with. Right, so I can just take away the floor and estimate it. Means that 1 plus root 2n is approximately 100. And then you get a very quintessential kind of like the surd manipulation task where if you want to estimate it, what do we do? Conjugate, yes. Right, so 100 is chosen to be nice because then you just needed root 2 to 2 decimal places, right? Which if you know 1.414, that's more than enough. Anyway, it's just an estimate, right? Even if your estimate is wrong, you can kind of adjust from there. So that's still okay. 1.41, which is therefore going to be around, this is 100 times 0.41, which is 41. Remember, estimate only. I am not claiming that this is the 41st term is it, but I can adjust. A lot of floor function questions. I think there was a junior round one question this year with a floor function that some of you found difficult. A lot of the floor function questions in round one especially, you kind of just use the approximation that the floor function does approximately nothing. And then after that, you use it to make an initial guess and you adjust from there. Very often that is a viable approach. In the round one question, you could also have done something like that, right? Just approximate that the floor function does very little and then after that just guess around that. In this case here, if I try n equals to 41, I can take out the 82. And then some of you will be concerned about whether I need to estimate square root 2 more and more carefully. No, I mean, if it's 41 root 2, I can always just move the thing inside. 2 times 41 squared, which I will fast forward the computation. Sorry, 3362, that's 1681 times 2. Fast forward the calculation. And it turns out that if you now check the nearby square numbers, 58 squared is a bit too big. So this would be 139. And 139 minus 41 is 98, which means that there are 98 numbers that are skipped so far. So if 98 numbers skipped so far, I know that the one for n equals to 42 will increase by at least 3. Right? Whether it's 142 or 143, I don't need to calculate it. I can if I want to, but I can already say that 2 more skipped will be 140, 141. Right? And so your answer is 141. 100, smallest number, not in S. Again, this is a sort of problem that can be asked in the SMO Junior, Senior, or Open because it doesn't use any complicated tools. But certainly it would be conceptually pretty difficult if it were in Junior. Senior, or Open is more likely to ask something like this. Now, that brings us to our final short answer question. Two traditions of this class. The first is that after we finish the short answer section, we will take a short 5-minute break where if you need to ask any questions, you can. The second tradition is that the short answer question, the final one, is often actually more difficult than the first proving question. And if you tried this question, you may agree that this is pretty difficult. I do not agree that proving questions are harder than short answer questions. It is of course true that the SMO round 2 is harder than SMO round 1. But there is a lot of room for them to have put in, let's say, harder round 1 questions than they currently have, with apologies to everyone that is already traumatized by round 1. They could have made it much harder. So if you were to look at some of the Russian contests, some of the China contests, you have to look at some of the USA contests, their short answer contests are way harder than ours, and perhaps the hardest one we get to try is just the AIME. So I do put some of these occasionally. I think it is quite interesting. It's also one of those cases where you can't argue with me whether your proof is right, because if your answer is wrong and your logic is different, there is a very low chance that it's just one small careless mistake. It is more often than not, if your logic looks different and your answer is different, that just means that there is a logical error. But if you think you're right, of course, you can just check your working. Right? The answer for this one is 2 root 3 over 3. So if anyone got that, then congratulations to you. Otherwise, let's do a bit of drawing. Omega is a unit circle. AB is a diameter. Unit circle means radius is 1. Right? So if you're waiting for some length to appear, no, radius is 1, right? It's the usual unit circle that we refer to when we say x squared plus y squared equals to 1. Center is O. CD lie on the same side of AB. So actually, in a way, I could have just drawn a semicircle, right? Because CD are both on the top half. CAB is 50 degrees and DBA is 70 degrees. Those of you that took the SMO last Saturday, did y'all get to bring a protractor in? What did they say about protractors? Yes, no, or no comment? No protractors. Wait, how come some of you are saying yes? That's disturbing. So I think it's no protractors. But anyway, for round one, it should also be no protractors. You do not need protractors to draw a diagram, but if let's say that you are doing it for your own practice, sometimes it's okay to use it just to get used to it. Yeah, ruler and compass. Okay, yeah. So it is generally meant to be that way. Ruler and compass are allowed. So you can draw a nice circle. In round one, probably no protractor. But in your own practice, don't feel bad to use a nice diagram. Even use GeoGebra or any other geometric software just to speed up your practice. You see, the thing is that we are busy people. If you're watching this on recording, that means that you were busy on Wednesday night with something potentially, right? We are busy people. And you do not always want to waste time on drawing diagrams. You have to once in a while know how to draw diagrams, but no, don't waste too much time. So anyway, for me, because I do not want to take a protractor and put it on the screen, you will see nothing. I would just say that if you were to put it around here, let's say this is 45 degrees, right? So 50 degrees, just adjust the point across slightly. And that will be a decent like estimate, right? So this would be somewhere around 50 degrees. Whereas if you want D, you will need to go a bit closer. So maybe somewhere about here would be 70 degrees. Also, 50 plus 70 is 120. And so I kind of suspect that I would want to extend this out anyway and get a 60-degree angle on top. But let's read the rest of the question first. It tells me to extend out, sorry, to connect AD and BC. Remember, angle in a semicircle is 90 degrees. A handful of you for which we just said this about 2 hours ago. So this is 90 degrees, they intersect at E. Then there is the perpendicular from O to CD. And the perpendicular from E to AB. Okay, so this is where some of your diagrams are going to be actively misleading. The moment you see a third perpendicular, that is actually the orthocenter of AEB. In other words, these are supposed to look concurrent. Let's call that point P or something. And the perpendicular from E to AB are concurrent at the orthocenter of triangle AEB, right? Of course, you can view it as APBE is the orthocenter. It's an orthocentric system, right? So B is also the orthocenter of AEP and so on. But this is just to say that they should be concurrent. I haven't finished drawing, have I? This is not going to intersect at P, don't worry. It is going to intersect somewhere, which is yet to be determined. I mean, as in where exactly on this is yet to be determined. Okay, but I do know that this angle here is 60 degrees. That's the thing that I suspected was useful earlier on. So now I'm asked to find OF. Now, this diagram here has one more thing that is a bit misleading, which I actually want to kind of tweak as well, which is that I said the perpendicular from O to CD. That should be the perpendicular bisector. And currently it doesn't look very bisectory and also not very perpendicular, right? So I'm going to just adjust it a little bit. I think this is a bit better because it's supposed to be that O is on the perpendicular bisector. Okay, so not a huge change, but I just think that it is important for us to note that down. This is also important because it will allow us to understand the role of F. Can someone tell me what is special about F? Okay, so I think some of you see it, some of you are a bit hesitant to confirm it. Okay, so here's what it is. From the perspective of this orthic triangle, remember that this would be the in center, this is the X center. So it's basically that this is going to be the thing in your chicken feed. Why? Well, basically, I'm a lot of times you first speculate what the configuration is, uh, and then you can confirm why that makes sense. But you want to recognize the pattern first. So because of the fact that uh, F currently is on PE and the perpendicular bisector of CD. Obviously, we know that that is going to be the definition of F, but we also know that PCED is cyclic. With diameter PE, right, opposite 90 degrees, which means that F has this role, but the circumcenter also lies on PE because that's the diameter, it's the midpoint of the diameter, and it is going to be that it is equidistant to CD. Okay, and so therefore it means that F is the circumcenter. And in particular, F is also the midpoint of PE. Okay, so we have found out what F is. F is actually the circumcenter of this circle, and it is the midpoint of PE. What is the significance of that? Well, the significance of that on one hand could be, now I can bash. And you would be right. If you just bashed it with some trigger, you could find OF. Because if I now know that F is the midpoint of PE, then I have enough length theoretically to work with. That would be true. There's, however, a nice thing we can say, because once I found that F is the midpoint of PE, that means I found a 9-point circle. Right? Foot of perpendicular, midpoint, and then midpoint of vertex to orthocenter. That's your 9-point circle. And so OF is the diameter, right? The 90 degrees. So that's what OF was all along. OF is the diameter of the 9-point circle of ABP, which means the length of OF is the diameter of the 9-point circle is the circumradius. Yeah, so if I call this thing R, then I can finally just use my the whole triangle here. I can use my extended sign rule to get R since this is 2. It is, as I will keep on saying in this class, very possible to have set much harder round 1 questions than what we have. So be thankful that our round 1 is still relatively boring, but not so conceptually heavy. Okay, so it is about the halfway mark. We will take a 5-minute breather here before we look at the proving questions. And if you have anything that you want to ask, feel free to do so. You can also ask about the class in general, because since this is the trial session, so it is meant to also be for you to see the range of difficulties from very easy to very hard. That's how this class will always be. Yeah, so I don't expect everyone to have understood everything. It depends on like your respective levels, right? So this class is that there will always be some questions you find easy, there will be some you find just right, and there are some you find too hard. I mean, you take the SMO, it's also like that, right? If you just took the SMO on Saturday, you cannot say, how come this question is too hard, no one can solve it. They do that sometimes. How come this question is so easy that everyone can solve it? They also do that sometimes. So I mean, this is not different in terms of like your own reading, your own learning. if you understand most of the solution except for one line, you can ask me about that one line, or you can also just go and Google it. So if I mentioned something which you weren't aware of, but otherwise it makes sense to you, right? So there are also going to be some questions where it is too hard. So like if you say question 2, remainder theorem, if you did not know what the remainder theorem is, just Google it. It is very straightforward, and after that you know it, you'll be like, oh yeah, it's just one line for that question. The geometry question we just did. If you know everything except you have not heard of the 9-point circle before, then you can go and check what that is. But if you do not know any of the things you have said so far and none of it makes sense, that just means that this question is at this moment beyond the range of questions that you are comfortable with. Then just don't worry about it for now. Right? It is counterproductive to overstress about any one specific question. Of course, some of you are having your scheduled class with me later in the week, or if you have your lessons with Peng Lao Shi, or if you're just like joining in to see how it's like. If you would like to vent your frustration at any aspect of the SMO Round 2, you may feel free to do so. I may not reply to you, but you are welcome to vent your frustration, express your confusion, annoyance, or any other forms of emotion. Okay, so we will come back. For the full solutions, uh, I will send it out to whatever groups. If you're in Peng Lao Shi's class, then most likely our admin will help to send over to those groups as well. What I will say is just that for most of these lessons, don't expect me to be writing out the proofs in like full paragraph form, because you do know that takes a while. That doesn't mean I don't want to because I'm lazy, because I do type them all out, right? And in fact, all the solutions that you normally see in the regular lessons are also typed out by me. So I do type out a lot of solutions. It's just that for discussion's sake, I think many of these questions, the difficulty is more in solving it than in explaining yourself. Once in a while, if it's difficult to explain yourself, then I'll focus more on the explanation. Okay, so let's come back. And we'll start off with this question number 1 of the proving section. Proof or disproof? Everyone's most feared problem type is the proof or disproof. It is possible to place the 36 factors of this number 175175 into a 6 by 6 square grid such that the sum of the 6 numbers in each row, each column, and the 2 main diagonals are all multiples of 3. Is it possible? If you think it's possible, then you can, of course, just summarize your construction in 1 or 2 lines. If you think it's impossible, you can also summarize your proof in 1 or 2 lines. Yeah, okay. So when you see a question on proof or disproof, what you should do is to postpone the decision as long as possible. You may sit on the fence as long as you can, just do some useful stuff. So this question is asking me about making the sums all multiples of 3. This is not a multiple of 3. It's clearly not a multiple of 3 because I've even given you the prime factorization. So it's not a multiple of 3. That means that all the factors are 1 or 2 mod 3. Now, if you want to then fill up this, I can almost say it's 1 or minus 1 mod 3. I would need to know how many there are of each type, because if it is yes or it is no, it still depends on how many there are of each type. So, uh, how many are there of each type? If it's the SMO Junior Round 2, some of you, I'm sure, decided to just, do a lot of listing. And it is not wrong to list out all the factors and check. Let's just look for something a bit nicer. And I think the nice way to handle this would be to just notice that I say it's not a multiple of 3. What is it? It's 2 mod 3. Now, if it's 2 mod 3, or again, negative 1 mod 3 if we prefer, that means that whenever you write it as a pair, 1 times 175,175, 5 times 35035, 7 times 25025, and I will stop before the factorization gets hard. Your pair of factors is just going to be 1 and minus 1 mod 3. So each pair of factors multiplying to it is just 1 of each. And so that means that without having to calculate, you actually have got 18 of each. Of 1 and minus 1 mod 3 factors. Okay, so if there are 18 each of 1 and minus 1 mod 3 factors, do you think it is possible to fill up the grid such that every row, column, and the two main diagonals sum to 0 mod 3? Is it possible? Yeah, so it is possible. And you have got two main options that are, straightforward. Of course, you can do it ad hoc. The first option you can do is just checkerboard. It is pretty easy to see why the checkerboard works because your diagonals are just going to be ones or all minus ones, and then the rows are all going to sum to 0 mod 3 as well. So this is a construction that works. And there is also another even simpler construction. Which is just to put a whole row of ones and then minus one and then alternate rows. Yeah, and this will be good enough too. Right, just alternate your rows all the way, and this would also satisfy the condition. It's not the only two, but it's the two easiest ones. So if you came up with a construction, I suspect it's one of these two. Or of course, you can rotate it to columns as well. Okay, so it is possible, as seen on the right. It is sufficient to write this. You don't need to go and say, now I will need to go and list out the actual factors. No need, right? As long as you know that it can be done. Okay, so now we get to the harder ones. I'm not going to comment too much on diagram drawing to save a bit of time. We will just get straight into a diagram. Circle should come first though. When you're drawing your diagrams, you would like to draw your circle before the line. Why does it keep on auto-correcting that far away from me? I think I will just use my own freehand line. Maybe I will say something about drawing the diagrams. Don't go and follow everything they do to the letter because sometimes it is not necessary. So for example, it's like if you want to go and draw this diameter, the diameter is going to kind of just block your path because I don't really need the diameter. I just need the point P and the point Q. So it is much more effective to just say that for it to be a diameter, it means there just be a 90 degrees here. Just draw it vertically like this. This is P. Draw this vertically up there, and there is Q. And yes, that if I just draw two of these vertically up, do I not just get a rectangle? Yeah, you do get a rectangle. All right, BCPQ is going to be a rectangle. That's what happens. I mean, the diameters is just the diagonals are the diameters which meet at the midpoint. But I don't need to put the center, and I don't need to draw the diameters. I don't even need to draw PQ yet. If it turns out to be useful, then later I will. Okay, X and Y are points on AB and AC respectively, so the XY is parallel to BC. And then now I have QX and PY intersect at R. And I'm supposed to show that AR is perpendicular to BC. In other words, is another vertical line. Okay, first thing to say, very possible to quadrum this question, don't you agree? Very possible to quadrum this question, right? Because you have a rectangle. So if you have a rectangle, I mean, you can just have a rectangle. You only really need to come up with a nice definition of this point A, and then everything else is kind of fine. So if you want to quadrum it, very possible. Now, having said that, this is a very typical example of where the conclusion feels nicer than the information, in the sense that this would be three vertical lines. Oh my gosh, I see so many similar triangles. I see so many equal stuff I want to use, but you asked me to show it. And so it would be good to use a phantom point argument. Because in reality, you just want these two dotted lines and this blue line to meet at the same point. If I define this to be perpendicular, so I will redefine my phantom point argument. So let the line through A perpendicular to BC be L, and so now I'm making this actually a line, and I will just let L intersect QX at R prime. Okay, so this means that I am making this a real right angle, and I am making this into a real straight line, although I realized that I better not because my drawing was not that good in the first place, and there's not actually that straight a line. So real straight line there. So of course, if I set this up here, I've got a straight line here, and I have got a lot of parallel lines. I also have the, don't forget this is parallel to this. So I want this to be a straight line. Basically means that I currently know that I have got this, my favorite hourglass pattern of they are similar. And I have got this, the thing which I do not yet know is similar, because I don't yet know this is a straight line. But if it is a straight line, it will be similar. And if it is similar, that will also imply it's a straight line. Right? That's just the same thing either way. So I think we can try our best to basically just length trace from one side to the other side, and it goes very smoothly. So a ratio that is going to be very useful to look at would be this one, because it's sitting inside a lot of the parallel lines. So in the yellow hourglass pattern, it would move to AR over QB, and across this parallel line XY and BC, it would run to AY over YC. Now, AY over YC. I want that to be similar. I've already got AR. Oh yeah, and then it's a rectangle, right? So I can move this over. Right, and then of course the others were just parallel lines. AR parallel to QB, and this one is XY parallel to BC. So AR over PC equals to AY over YC. And you have got that part is a straight line, so the alternate angles are there. So SAS tells you that they are similar. I realize I just use R the whole time instead of R prime, but that is easily rectified. Yeah, R prime Y is similar to CPY. So that means the angle in the middle is equal. And that means that the PYR prime is really a straight line. Which is what we wanted. Because it means that R equals to R prime. They are the same point, and AR is perpendicular to BC. So a lot of you have asked me about phantom point arguments, like when is it valid, and when do I want to use it? Well, it is valid if you are not assuming anything. That's it, right? You don't assume anything. But how does it work is normally that if you would like to use the thing you are supposed to show, then look for some point where it seems to be like concurrent. Its very existence depends on concurrency, let's say. These few things all go through the same point. And see if you can swap one of the conditions for the thing you want to show when it's very obvious that point is unique. And that's the basis of a phantom point. Okay, so next up is this algebra question from the Bulgarian Math Olympiad. I am always for this class, as those of you who are regularly here know, sweeping across many random countries competitions apart from things that I set, and very rarely do I actually take SMO questions because uh, I think you have practiced them or you will be practicing them. So let's do some things more unusual. Also because the SMO has had a fair share of 奇怪的毛病, you know, all the weird stuff that they do. Everything you complain about, I'm well aware. So there are nicer questions in other competitions sometimes. This is quite interesting because there aren't so many absolute value based questions that are not also a massive bash. This is quite nice. N is a positive integer, determine in terms of n the minimum possible value of this sum of absolute values where your x1 to xn are real numbers whose absolute value sum to 1. Again, to get a bit of canvassing on how many of you have thought more about this problem, do you have an answer that you know or think is correct? Okay, so when you want to try, you always try some small cases, right? So if n equals to 1, obviously it is 1. That's just one thing. If n equals to 2, now you're looking at this. You want to minimize this, and you have this is equal to, this sums to 1. So how do I make this as small as possible? I can see that half and half seems very promising. Can I show that it's at least half? Well, my best tool, right? So my best tool in terms of showing inequalities for absolute values is the triangle inequality. Now, let me just state, right? So the triangle inequality, of course, the most traditional form is that it looks like this. But realize that because of the fact that you can replace negatives, you can also replace your x2 by negative x2, which will leave the right hand side unchanged. So the triangle inequality can be used on these kinds of things too. So when I looked at this here, my first thought is, okay, am I able to do this? Well, I can just apply this directly. But the problem is that this definitely does not look like it is less than half. It is more than 1. And that's because the equality case of your triangle inequality is when the signs are the same of these two, which means that here is x1 and x2 have different signs. So I do need to think about how am I going to show it, is one thing. The other thing which you may have realized is that, am I not going the wrong direction? I want the minimum, right? Why am I showing that it's less than or equals to something? Also true. So I need to figure out how I can use the triangle inequality on this in the correct direction. Which I then realized that, oh, I could say that this plus, let's say, this, if I use the sum of it, it can be written in this form. Now this is true. You can also swap the variable order and say that it is greater than or equals to this. But both of them, if I now use it here, if I use the first one, I'm never going to get half. If I use the other one, it will just give me this, which again is never going to give me half. This one, if I just wrote this here, I don't know anything. So then I realized that if my equality case is when x1 equals to x2, in my opinion, that seems the most logical, and I don't want to split a lot of cases, the way I can use the triangle inequality is to make sure that after I use it, I have an equal amount of both. And so I can start by just adding a 1/2 here first. And then when I use my triangle inequality, there is half. Okay, so this means that I know that this is the answer for n equals to 2 is really half because I've shown it's at least half and I found the example that gives me half. Okay, very often the first non-trivial case is going to give you a lot of info. And then you ask, is this going to generalize? So you try to see if you can use that approach on the next one. Okay, so my idea is that if now I've got 3, I need to make sure that I adjust them to perfectly give me an equal number of each. And I can just continue from before in some way. I'm not going to induct. I'm just using the logic. You see, there's induction where you literally use the previous statement. That seems a bit hard to do here. Or there's just repeat the logic. So I can say I will start off by giving this a 1/2. I will also reverse the order around just because I could always have reversed it to make it a bit more intuitive. Now this will give me 1/2 and 1/2. So to meet at the middle here was 1/2. To meet this one, I will need a quarter of this. So let's try this. Now this is my triangle inequality. Now, hang on. Am I allowed to open up this? Well, I can, right? Because it would be that I am now subtracting this. And so if I want to continue to go downwards, I want to subtract something more. So I can further split it open entirely. And lo and behold, right? This one was, after this one step, it was half. Now I basically managed to make them meet at 1/4. Okay, and then I asked myself, uh, can equality hold? In order for equality to hold, my x2, x1, all of these, when I did this constant, this must be 0, right? In order for this thing to be okay. So x1 should be equal to x2, and x1 plus x2 should be equal to x3. And so x1 should be 1/4, x2 be 1/4, and x3 1/2. Sure, it works, right? You'll get 1/4, 0, 0. So it is not too much of a spoiler to say that this argument continues to work, right? Because if it can work for 2 and 3, it is not too hard to see why it will continue to be true. And so that means that your answer, if the pattern just continues, it's just 1/2 to the n minus 1, and your construction and proof can be generalized from above. Yeah, the Bulgaria Olympiad is not the same format as us, so it's not question 5, it's the hardest one. They have I think it's like the typical IMO format of 3 questions. So Q5 is the middle difficulty one. It's definitely not the as hard as Q5 of open round 2, but it's an interesting idea. And I think it's one of those inequalities that you can actually try small cases on. You do want to look at any time when something depends on n, whether shrinking it would be meaningful or not. Here it's definitely meaningful because it just looks like you're just adding one more term at the end each time. So no good reason why it would not be nice. Yeah, you can induct in a way if you were to say that for any given, let's say, x1 to xn minus 1, for any given sum, I can decide on what the minimum is to some extent, but you need to be careful because like your xn is also related to it, right? So like, do I want to continue using the same construction for the front? No, we didn't really use the same construction here. We scaled it down. But how do you know that you just want to scale it down is not instantly clear, I would say. So you need to be careful if you're trying to write an induction proof. I think it can be done, but it is a bit challenging. Easy to fix solve. Which leaves us with 15 minutes to do a C4. Uh, but it's okay. This is a question that is pretty cute. It is also, the wording is far more complicated than it actually is as a problem. I'm not saying it's easy to solve, but the problem statement is made to be a lot more complicated than it actually is. So the statement is saying that Paul has a strip of 1 to n squared, basically. Right? It's just a long strip. So let's use n equals to 3 for example. Paul has a strip that just goes 1, 2, 3, 4, 5, 6, 7, 8, 9. Paul wants to chop it up in a way that would allow him to then translate without rotating or flipping. So just put them into a 3x3 square where if the square in the ith row and jth column is labeled as this, then okay, so this is very much something I want to write in a modular arithmetic form. Aij is I plus j minus 1. This just means that the first row, first column should be 1. Then after this should be 2, and then this should be 3, or just 0 mod 3, and then after that 4, which is back to 1 again, and 2 mod 3. Which reminds me that actually I can just change this also to just 1, 2, 3, 1, 2, 3, 1, 2, 3. So I want to chop this up. I think it is pretty obvious intuitively how one might want to chop this up. You just take 1, 2, 3, comes here. Then after you say, okay, 1, 2, 3 again, this one I will chop up like this. And then after that, 2, 3, and 1. And then after this one, okay, I chop down here. And then this comes here. And then you see that this will still work in general. It's not very hard to continue with this. You have got 1, 2, 3, 1, 2, 3, 1, 2, 3. Well, if I had 1 to n, I mean, you can think of it as chopping up the square also, right? Not just chopping up the strip. So in terms of getting an answer for this, which we would have a quite high degree of confidence of correctness, it's not very hard to do, right? This is just going to be like this. You need to chop up either a strip to look into this, to look like this square, or you chop up this square to make it look like that strip. But you could, I think it's easier to just use the strip and say, okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so it is going to be the case that your answer looks like 2n minus 1. You split every row of the square into two parts except the top row. Now, I'll just tell you the answer is correct. It's not very shocking, right? It's not really breaking news. But how do I do this? Well, maybe we are thinking of a very simple proof, and you should for combi. And if you're taking open over the weekend, you should think of the simplest potential proof. It doesn't always work, but you just work from there. So my first thought is, can I say that each row of the square must come from two pieces? Maybe with one exception, right? That's how 2n minus 1, right? So far yours is the top row. Can I say that each row of the square must come from at least two pieces with at most one exception? Well, the answer, unfortunately, is no. Because why? I could leave the first two rows untouched. And I sort of say, okay, I will put 1, 2, 3, 4, and then I will reserve a space for my 2, 3, 4, 1. Okay, come and give me a 1. So I say, okay, I give you a 1. Now, 1. In fact, I can even say that, oh, by the way, please reserve a whole space for this 3, 4, 1, 2 also. And what do I need in between? I need a 2. Okay. 2, and then 3, 4. So clearly that explanation does not work. And furthermore, I can do a mix of these. It's not just these two extremes. But it is 2n minus 1 still. It's 7 pieces here. So I am looking for some kind of explanation of why that it seems to be this. But it cannot come from me just talking about the row having at least 2 pieces, right? That's not true. Okay, so how do I actually handle this? Now, I can't really give you like a full motivation of why you must do what I'm about to say, but I can say that this is how the thought kind of comes to me. So I noticed that when, let's say I was chopping it up, right? There is this 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, then 3, 4. Previously, it was 1, 2, 3, 4. And then after it's like, I say that, okay, I just chop this thing up. 1, 2, 3, 4. And then after that, the next one was 1, 2, 3, 4. And then after that, 1, 2, 3, 4. And this is the thing that I did. Now, I realize that in terms of these pieces here, the pieces themselves are pretty boring because it's 1, 2, 3, 4, then 1, then 2, 3. I already know what these are. You're just repeating in a cycle. And so, really, I can just think of the starting points as being enough to describe it, right? If I know the starting point, because the strip cannot be longer than 4 steps for, let's say, n equals to 4. So if you were to tell me that your starting points are 1, 1, 2, 2, 3, 3, 4, I know it looks like that. If you tell me it's 1, 1, 2, 1, 3, 1, 4, I also know it looks like that. And so it means that you are essentially just traversing through these alone. And whenever there is some sort of like that you are just trying to make as few pieces as possible, means as few starting points as you can. That's like shortest path. And shortest path has to do with graphs. And so I'm going to take this as a graph question. Kind of. We have a lot of work to do in order to understand it as a graph. But basically, what I am saying is that if and this was my path here, I would like to minimize the number of edges or vertices, number of steps. So the question is, for pieces, can they be joined together in a single row? Uh, it's sort of like these are my pieces. Now, of course, this is slightly modified, right? 1, 2, 3, 4 is not 1 to 1, but I'm sort of saying 1, 2, 3, 4 is sort of waiting to join to a 1, and it's like dominoes being glued together. Right? 1 to 1, 1 to 2 can glue together because 1, 1 is means that after this, please give me a 1. This 1, 2 means the first thing that you put is 1, after this, please give me a 2. So it's kind of like dominoes. I am thinking, therefore, about the fact that if I were to view each piece as this, the question is, can I just fit this together to be dominoes, like in a game of dominoes? I do not actually need to worry about whether it is 1, 2, 3, 4, 1, 2, because if I'm able to fit this together, it will be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, as long as I start at 1 and end at 4. So this is my thought. Technically, there is, yeah, the final piece is sort of like just for 1, if I were to consider it as that. So it must start at 1 and end at 1 is a more precise way of putting it, because I'm saying that if I were to use this piece somewhere else. Right, so for example, in here, I could have taken this and put it in front, and that would have been valid. Sorry. And likewise, I could also have taken this piece and put it in front, and that would still be fine. Now, these are my edges, therefore, directed edges. And I am looking at my original grid and saying that each row basically was 1 to 1, 2 to 2, 3 to 3, 4 to 4, according to this notation. And so I am sort of chopping it up and saying that it was a path from 1 to 1, a path from 2 to 2, 3 to 3, 4 to 4 that I split up. Let's say in the case of here, I split it into 4 to 1, 1, 2, 2, 3, 3, 4 below for myself. But this into this is still a cycle. And so the whole question, if we were to set it up properly, is stated as follows. Right? Your grid, in terms of n, is going to correspond to n cycles from 1 back to 1, 2 back to 2, and so on until n back to n. The cycles can be a single self loop. I want to minimize the total length of these cycles. Which is the number of edges. And I want to make sure that the union of these cycles means that all of these edges can form this thing here. And what is this thing here? This thing here is an Eulerian path. A graph with an Eulerian path. Eulerian path means through all the edges, and all of these are edges. So a graph with an Eulerian path. My question is, why does this need at least 2n minus 1 edges? Well, when it comes to enough edges, it's always to do with like enough to connect the graph nicely. That's usually how the minimum number of edges in graph theory works, right? And if you have got n cycles, we know that in a tree with no cycles, n vertices will have n minus 1 edges with no cycles. Now I've got n cycles here, which is basically telling you that you have got an extra edge for each cycle that was unnecessary. So the Eulerian path is not really going to be used in its full form. It's just that it's connected. But moreover, it means that because all of these cycles there are not just paths, they are cycles, we can remove one edge from each of these. And a connected graph, if you remove an edge from a cycle, it's not going to disconnect it. There's a cycle, right? So if you remove the edge, there was an alternative path. And so this is to confirm our argument that you have at least, for a connected graph, so after removing n edges, leaves at least n minus 1. So there's at least 2n minus 1 edges. Okay, I know I've lost some of you. Now before you go, just to say, right, this is hard. And if this question were to show up in the open round 2 on Saturday, I am very certain that less than 10 people will solve it. So this is the range that we're going to be talking about for all our subsequent lessons, not sitting in this level of difficulty, but reaching to this level of difficulty, which is why there is theoretically something that should be hard enough for everyone, such that no one should finish all the questions so easily, but also some very easy questions at the front, so that nobody would say that the lesson is impossible. I couldn't do even one question. Right? That is something that should not happen. And if you are at that stage right now, that just means that this is a bit too difficult for you at this moment. And you can just wait another semester and see how it goes. Okay, so some of you normally ask to copy down some stuff. I will upload this, meaning the video will be there, the annotations will be there, the solutions will be there, so you don't need to worry about copying anything, right? It's already 9:20. So I will let you go. If you have any questions, you can stick around. Otherwise, good night. And in terms of registering for the class, you can always check with our admin. They'll give you a bit more details on the logistics of that. Okay, so bye-bye and all the best if you're taking the open round 2 on Saturday as well.